Good morning. So myself, Dr. C. Vijay Kumar, Associate Professor, Department of Mechatronics Engineering, K.S.Rangasamy College of Technology, Tirchandur. Today we discuss about the topic of mechanical energy based non-conventional machining process. So under the mechanical energy based non-conventional machining process, first we see the introduction. What is the mechanical energy based process? Then what are the process undergone of that mechanical energy based process? So many mechanical energy based processes are there. Mechanical energy means the energy is converted into one form to another form, then remove the material. So it is called as a mechanical energy based. So the first one is the abrasive jet machining process. So the abrasive jet machining process, behind the principle is the machining process works on the basic principle of abrasive erosion. The abrasive is hit into the normal workpiece or work surface. Automatically the workpiece will be the unwanted surface is erode and then remove the unwanted materials. We get a final shape. It's called as abrasive erosion. If a high velocity abrasive particles strike on the hard or brittle workpiece, it removes some metal at the striking surface. This metal remove process takes place due to brittle fracture of metal and also due to micro cutting by abrasive particles. This is the principal process of abrasive jet machining. This is the entire structure of abrasive jet machining process. The top one is a nozzle. The nozzle is a center. We are having a hollow. The hollow, we are inserting the abrasive particles and the air with high pressure. This is a red color dot. Under the gray color is a workpiece. So fitted into the workpiece under the nozzle, we started the process. At the time we supply the air with abrasive particles. The high pressure is supplied through nozzle. The high air pressure abrasive particles are hit into the workpiece. Wherever the high air with abrasive particles hit, at the particular place the metal is removed. That is called as abrasive erosion. We are maintaining the nozzle and workpiece gap is 2 mm. The velocity is 200 meter per second. We are supplying the high velocity of air with addition of abrasive particles. The abrasive particles hit into the workpiece, then automatically the metal will remove from the workpiece, then we get a final shape. So wherever we supply the high pressure abrasive particles, at the places the metal will removed. This is called as a abrasive jet machining process. The process, how it's working, you see, the first gas or air is compressed into the gas compressor. There are the density and pressure of gas increases. Once the compressor work is to increase the gas pressure and density. Once the pressure and density is reached at a maximum limit, now this compressed gas sent to filtration unit where the dust and other suspended particles are removed from it. Once the cleaned gas sent to the dryer which absorb moisture from it. It's used to avoid water or oil contamination of the abrasive powders. Now this clean and dry gas sent to mixing chamber. The mixing chamber is to work on that the gas and abrasive air and abrasive is perfectly mixed. Where the abrasive feeder feeds the abrasive particles in it, the abrasive particles is about 50 micrometer grid size. The high pressuring abrasive carried gas sent to nozzle where its pressure energy is converted into kinetic energy. Earlier we discussed the mechanical energy means we converted one form of energy to another form of energy. This converted energy used to remove the material from the work is called mechanical energy based non-conventional machining process. The same line we see where its pressure energy converted into kinetic energy. The velocity of abrasive particle leaving the nozzle is 200 meter per second. The standoff distance between the workpiece and the nozzle is about 2 mm. Now these velocity abrasive particles impinge on the workpiece. The high velocity abrasive particles remove the material by micro cutting action as well as brittle fracture of the work material. The abrasive jet machining process advantages applications. What is the advantage we are using this abrasive jet machining process? We see high surface finish. It can machine heat sensitive material. It is free from vibration. Insulation cost is low compared to other non-conventional machining process. The thin section can be machined easily. Where we are using this abrasive jet machining process called as application, where it is used in drilling and cutting of hardened metals. It is used for machining brittle and heat sensitive material like glass, quartz, mica, ceramic, etc. It is used to manufacture electronic devices. It is used in debugging small holes and small critical zones in machining parts. The abrasive jet machining process have some disadvantage. One of the disadvantages is low metal removal rate. The speed of metal removal rate from workpiece is very low. Then abrasive particle can be embedded into a workpiece mostly in soft metals. Nozzle life is limited, so it needs frequently replacement. Abrasive particles cannot be reused in this process. It cannot use for machine soft and ductile material. The next mechanical energy based non-conventional machining process is water jet machining process. Instead of abrasive, compare the abrasive jet machining process, water jet machining process. Instead of abrasive, we are using high speed, high pressure water into the workpiece, then remove the excess material or unwanted material from the workpiece. It is called as a water jet machining process. We see water jet machining is a non-conventional machining process in which high speed jet of water is used as the tool to remove the workpiece material by erosion. In order to generate such a tool, the water is first pressurized. You see the entire unit of this water jet machining process. First one is a fluid supply. Fluid supply, first we loaded the tank, loaded the water reservoir to this fluid supply tank. Then the fluid supply tank is opened, the pump is shut from the water from the fluid supply unit to accumulator. After that the water is sent to control unit from the accumulator. Once how much level of water is sent to the nozzle, the control unit will be decided. After the control unit, they supply the water to the valve. The water is supplied again to the nozzle. The nozzle is a small hole, is having a high pressure vessel. So the water is supplied through the jet. By using this nozzle, we are getting a high pressurized water. The high pressurized water with the help of jet passed to the workpiece. Where the workpiece is removed, you already decided that place we can supply the high pressure water, then automatically the metal will be removed. Once the metal is removed, the water is go for the outside. That is the water jet machining process. This is the metal removal rate of water machining process. The metal removal rate is the amount of material erosion from the workpiece per unit of time is called as a metal removal rate. The speed of the machining of workpiece is high. The machining rate is always desirable because it is directly related to productivity. So these all are the water jet machining process and the abrasive jet machining process under the mechanical energy based non-conventional machining process. Next module we see some other energy used to remove the materials from the workpiece. Thank you for your passion listening. Keep learning, growing.